paper. I got to get to it. All right. Find the derivative of y with respect to x. Find me dy dx for number 1. Go, quickly. And I'm just going to look to see how you do it. How are you used to your functions being given to you? Y equals. Can we make this y equals? Yeah, so let's do it. So, negative 6y is equal to negative 4x plus 18, divide by negative 6, and I get positive 2/3 x minus 3. So now it looks like what you'd be used to, right? Gave you the y by itself. Find its derivative. What do you get? 2/3. All right, so that y prime, exactly the same thing as this. What does it mean? We took the derivative of y with respect to x. That's actually what it says. This one. So if I wanted to take this guy's derivative, what would you do? What would I do? Consider we just did number 1. Same thing. Try to get y by itself. Go. All right, so you try to get your y squared by itself. Then if I want to get rid of that y squared, square root, but if you take the even root of both sides, plus or minus, okay. Y equals plus or minus the square root of 4 minus x squared. Y equals a plus or minus of 2 minus x. Thumbs up if you got that answer. Thumbs down if you did not get that answer. Kevin, why didn't you get that answer? Well, yeah, you're a little ahead of me. Just for the y part. Yeah, is that the same answer you got for the y equals? Just the y equals. No? Okay. Why? Square root of negative x. Okay, I'm hearing a little bit of mumbling. Ty, what about you? Wow, that's really good. The way you explained that is actually really nice. You knew that if you were to square what you got, it should get you back the original. That is a correct statement. And no, it does not give you back the original. Right. What is wrong with what's on the board because you looked at it like I was crazy? Huh? Nothing's wrong with it? You said everything's wrong with it. What's wrong with it? What did I do wrong? Because we saw half the class got it wrong. Just so you know, that's not the right answer up there. No. Don't second guess yourselves. Right, what happened? Oh, you did it a different way? Okay. Someone want to tell me why I'm wrong on the board? Thumbs up if you think you know why I'm wrong. Just curious. Okay. Esma, what do you think? Well, square root, because you can't square root each term. Why not? Because there is a minus in between. That is why you can't do it. And Ty gave us the awesome answer of why 100% it doesn't work. Because you should be able to square this guy to get this guy. And it doesn't work. It does not work. Half of you had that. Half of you thought you could just square. It looks so nice. It makes you want to do it every single time. It does. Trust me. I know. Because your class and the other class, half of you get that wrong every single time. You can't do it. You gotta fix those habits. It does not work. This is as far as we could go. So this problem kinda sucks. Because you'll have 2 answers. If I asked you for dy dx, you would have 2 answers, a plus or minus answer. It's kind of a pain in the butt. If I asked you to solve this guy, what the? I would love, how do I make this y come out of there? Can I divide by sign? Remember how we read it. How do we read it? Sign of. So can I divide by sign? No, you need an inverse operation. So you would have to take the sine inverse of both sides. But when you do that, you still got this thing hanging out outside. So could I solve this for y? I actually probably couldn't. You guys magically would. You always feel like there has to be an answer. So you would make it work out to have an answer, but it would be wrong 100%. But you'll write me something, I guarantee it. You do every time. You're like, oh, it has to work. She told me to do it. It's going to work. It doesn't. You'd have a hard time. And it's that of. That sign of makes it very difficult. So what we're going to learn today, you can find its derivative. You just won't do it the way you're used to. Okay? So, on that next page, let's first talk about wording, because the wording is important. If I asked you to find the derivative of y with respect to x, so what does that mean? If I ask you, take the derivative of the variable just y, that's what it says? Well, this is actually the answer. Take the derivative of y with respect to x. That is physically the answer. If I ask you to take the derivative of x with respect to t, normally, if I just asked you find the derivative of x, what would you tell me? You would tell me it's, come on people, the derivative of x is 1. Every single one of you would tell me it is 1. Why? Because all the problems we've done were with respect to x. This one's with respect to t. So this one now becomes this. The derivative of y with respect to z would be, so why does that work out? Let's back up to this guy, the middle one. If I changed it and said with respect to x, how would I write that? The derivative of x with respect to x. It's 1, which is the original answer you probably would have given. I'm going to add one more thing right here. Some people had a hard time in class with this. If I ask you to take the derivative of 2y, what do we do with the coefficient? Just put it there. So now the new question is, what's the derivative of y? With respect to x? Okay? Now we're going to do more. So I'm going to start you off by finding derivatives of just singular terms, just pieces. And then you're going to put them all together. So I say chain rule because that's where it comes from. That's why you have to do this lesson after you learn chain rule, because it actually comes from chain rule. So we're going to do the chain. Isaac, give me the first part of the chain rule. 3 parentheses squared. Beautiful. All right, 3 parentheses squared. Yosef, give me the second part of chain rule. So close. He did the derivative of the outside in case you're lost in the steps. Leave the inside the same. Perfect. X. And then the very last part, let's see. Travis, give me the last part. What do I do as the third part of a chain rule? The derivative of the inside. So watch and listen to the way I say it. I want to take the derivative of the inside. It happens to be x, so I'm going to restate it. Find the derivative of x with respect to x. What is that? 1. What is it really? Well, really, in your notes, this one time I'm going to have you write it. That's really what it is. Do you see why we didn't do that every single time for the past however many sections we've been working on this? Pain. It's worthless to some extent because you're going to cancel it every single time. Now let's try this guy. It looks almost exactly the same. So it's chain rule. I'm going to copy down what you said already. 3x squared times the derivative of the inside. Nick, read me how I would read that if I say, now I want to multiply by the derivative of the inside. I want you to read me how I would say it if I'm telling you my step now is the derivative of the inside. So what are we taking the derivative of? Over dt. Why? Because if I read it, I'm taking the derivative of x with respect to t. And if you read it that way, it tells you what you write. I am writing the derivative of x with respect to t. We'll do 2 more and try to summarize a different way so it's a little easier for some people. Try the next 2 real quick. When you're done, check with your group members to see if you actually match or if you're just writing nonsense. Malky, I'm going to come to you for your number 3. You ready? What do you get? Times dy over dx. Jamie, I'm coming to you for number 4. Matthew, I'm coming to you to ask you the question of, what's a nice way to summarize if I'm going to have one of these differentials or not? So this guy didn't have it, but this one did, this one did, and this one did. Do you notice a pattern? If there's more than one kind of variable, okay, that's a good way to start. Isaac? If the with respect to variable matches the variable whose derivative you're trying to find, then it'll equal 1. So will I have a differential? No. Perfect. So then if I want a differential, it would be because the with respect to variable is not the same as what's inside there that you're trying to take the derivative of. So that way you always know if you're going to have it or not. It's when you take a derivative of a variable with respect to a different variable. So I take the derivative of x, and I'm doing it with respect to x, no differential. If I take the derivative of t with respect to z, I'm going to have one. Does that make sense to everyone? Do I have a thumbs up if you do agree and understand and completely we can move on? Okay. All right, so with that, now we want to do some harder ones. These guys. These guys. A little bit harder. They get uglier as you go on. I think 7 and 8 are a little bit. These are a little bit more of a pain than you would think. Why? Because there's a product rule hiding. If you went crazy and just wrote me 2 dy dx, you missed it. It is a product. When you do a product, identify the product. It makes it easier to not make the mistake. Easy to not make that mistake. So Wright asked me a good question. He said, do I have to do my product this way? No, you could do 2 times the product of xy. Okay? Which just means your answer will have a 2 in front of the derivative of the product. That's actually correct. Completely correct. Why don't I do that? Because I don't want you guys to forget to distribute. So most of the times, I'll make you do your product with the value. I don't care which way you do it. Just don't make a mistake. Don't forget to distribute if you do this way. All right, so this guy, I'll come down here. Leave the first one. Derivative of y with respect to x. So, and I don't need a parenthesis. Do it in red. Derivative of y with respect to x. Plus y. Do I need a dy dx here? Or do I need one? Thumbs up for I need one. Thumbs down for I don't need one. Baldrick, why don't you think I need one? But I have a y. I don't know why you're telling me that I'm not supposed to have that. You told me what you wrote instead. Why don't I have that? Good. You got it. You got it. Most people think anytime you write a y, you automatically write dy dx. Can someone clarify when I will have it? It's not when I write y, when you take the derivative of y. So be careful with that. I'm trying to clean up all the weird things that happen every year. All right, so once I take the y, leave it alone, multiply by the derivative of 2x with respect to x, that's where the 2 comes from. Okay? You'll do more with this. Right now, I just want to teach you how to find the terms, and then you'll put them together. You'll do things like find the derivative at the point x equal to 5, find the horizontal tangent of, things like that. All right, this guy, almost exactly the same, but now you're doing it with respect to t. So, leave the first one. Derivative of y
with respect to t, double check that you have a dy dt, please, plus, leave the second one, times the derivative of 2x, but with respect to t. So you still have a 2, but because you have the x, dx dt. Have I lost anyone? Anyone confused here? Because we're about to go into, I think, some harder ones. Example 7. So, you're still doing derivatives the way you know. How do I do a cosine of y cubed? What rule? So this is actually a legit, you can see it, there's a chain. So, derivative of my outside. Alright. Let's see. Derivative of my outside, what we get? Negative sign, good. Leave the inside the same, I got that part. Jasmine. I'm going to take the derivative of my inside. What do you get? dy over dxy. Yes. And is the respective variable x? Yes. So you sounded a little unsure. I'm confirming 100% that that is the case. Okay? Good. Good. But then now I want it with respect to this guy with respect to t. So you'll still start out almost exactly the same. Just like you guys told me. And then Jasmine gave me the times, the derivative of the inside would be 3y squared, but then multiplied now by dy dt. If you can do term by term, the rest of it's going to be really easy. So using implicit differentiation, just to save a little time, I'm just going to do an example problem for you. Save a little time for us. All right, we'll do A and B, and that's where we'll end. All right, find the derivative with respect to x. This actually says you have to solve for the dy dx. That's actually what it says, solve for it. So, first term, what I taught you before was how to just do a term. Now we're putting it into an equation. So, 2x, do I need a differential? Because I'm doing part A, with respect to x, do I need one? No, good. Plus, 2y, do I need one? Yes, dy dx, what's the derivative of 9? 0. This is not the answer. You're supposed to solve for dy dx. So get this by itself is all it's asking you. One last step. What it means, get all the terms with the dy dx on one side, get everything that doesn't have it on the other side. And then divide by. So we get negative x over y. And then over here, we're going to do with dt. So what do we get? 2x, but we're doing dt. So what do I have now? dx dt plus 2y dy dt equals 0. So if I want to get dy dt by itself, that's right here. Move the other guy over. I'm going to move over a little bit so I have more space. And then divide by that 2y. Most people always ask me a question about the stacked fraction. You get to leave it if it's a differential. So divide, I'll still have negative x dx over dt divided by y. You can leave it like this, even though there's a stacked fraction because it's a differential, or if you don't like that, you can also rewrite it like this. That means the same thing. That's just another way to write it so it doesn't have that stacked fraction. Stacked fraction is okay when you're using a differential. You don't separate, you don't try to do anything weird with that. These have to stay the way they are, a differential. Okay? If you feel like you're a little worried to do the rest, you're welcome to stay. I can do one more example with you if you'd like. I'll just look to see if anyone's still here. If not, you may go finish up this before you do numbers 1 through 13. They will be much easier in your book. Way easier in your book. That did not work. Pause. So, you know this one's done, right? Yeah. Okay. So then, this guy? Let's walk through it together, because I'm going to record it for the other kids. All right, so if I want to finish up, I'm going to get to where you were. So hopefully we have 6x. I'm doing this with respect to x to start. So that would be, all right, plus negative x dy dx plus y times negative 1 plus 4y cubed dy dx is equal to 6 dy dx. So just double check that you have your negative on the outside, I believe, right? Okay, so we have everything else the same. So if you ever want to solve for a variable, what do we do with that variable? We collect them all. So I'll collect all the ones with a dy dx. That's this one, and this one. So I'm going to move them to this side, okay? Negative x dy dx plus 4y cubed dy dx minus 6 dy dx. And what do I do with everything I don't want? Move it out, right? Because they don't have the variable that I need. So this 6x and that negative y, so negative 6x plus y. Good so far? Yeah. If every single one of them has it, what do I do with it? Leave him alone. You don't distribute. It's already distributed. Take it out. It is called a GCF. You forced it to be the GCF. You made it happen. So now we take it out. If I take it out from every single term, now you can see why that helps. If I take it out, then I'll always be able to divide by all those terms. So my final answer to finish off this guy would be negative 6x plus y over negative x plus 4y cubed minus 6. Okay? All right. I'm probably going to have you only do a part B with this one problem. So I think there's a 3 and 4. You only have to do part B for number 2, 1 and 2. Did you guys hear me? So for the worksheet, you don't have to do the part B for numbers 3 and 4 because they get really, really long. So you only have to do it for 1 and 2. Okay? Where it says part B, you're only doing it for numbers 1 and 2. 3 and 4 will take forever. All right, right? You're good? Okay.